So in this video, I write some code using TDD to find out, is TDD design, requirements analysis, modeling, or testing? And the answer is all of the above, as we'll see. So I'm just going to spend a little bit of time looking at test-driven development and how it relates to testing. Because we hear a lot of different things about test-driven development in terms of, well, it's not really testing, it's design, or it's building requirements, or I don't know, pretty much anything. Now, I think there's a lot of overlap between TDD and testing, but there's also a lot of overlap between TDD and requirements analysis and design and modeling. And that's also because there's a lot of overlap between testing and requirements and design and modeling. And really, when we're involved in a software development process, we're probably doing all of these things. So what I want to do is go through a process of TDD, and I'm going to work on actual code. We're going to write some code, and we're going to explain it in terms of what are we doing with TDD and how what we've just done relates to testing. So you'll see an introduction to TDD, and it'll be an introduction to testing, and the thought processes that overlap. And then we'll have a better idea. I'm not going to try and pass judgment. I quite like TDD. I use it all the time, and I test. So I'm not criticizing anything at this point. I just want to try and build a model in my head of what we're trying to do. So I'm going to start. This is in the Java Scratchpad project on GitHub. So I'm just going to start by creating a new package. I'm just going to call this TDD Explored. Let's do that. So I think as a simple example, what we'll do is we'll create something that will add two numbers. So I'm going to create a test. I'll call it calculator. And in here, so what I'm going to do is I'm just going to start creating some tests so that you see the process of TDD. And then we'll come back and revisit it. So the first thing I need to do is create that test method. So that's in. So let's can add two numbers. There we go, because I'm going to add two numbers. Now, at this point, I haven't tested anything. I'm essentially at this point in a design phase, but let's keep going. So can I add two numbers? Well, not yet. So what am I going to say? I'm going to have a thing. So I'm going to say a new calculator. Let's have that. That doesn't exist yet, so let's create that. Create the calculator in the main rather than the test. There we go. So I'm going to use that. So new calculator dot add two numbers. I'm going to add 0 and 0. Why not? Now that method doesn't exist yet, so let's just create that. Adds to int and first and second. There we go. Now you can see that I'm only building up just enough code to meet the requirements of this test. At this point, I haven't run the test, but you saw that there were syntax errors, so I'm just getting rid of the syntax errors. So with TDD, I'm writing down the code I want to see. I'm getting rid of syntax errors. I'm getting rid of those first. But at this point, we haven't written a test yet, so let's assert on this. So I'm going to do an assert, and I'll say assert equals that 0 plus 0 is actually 0. And now this doesn't return anything yet, so let's make that return. So anytime I get a syntax error, I have to fix it. That's part of the TDD process. So let's make this return an int. Then it's going to complain here. So to make the test pass, I know I just have to return 0. So there we go. Can we add this? So let's find out. We run it. And that should pass. Great. So I've added two numbers, 0 and 0, and they are 0. Now, what we have here, so you saw the basic process, writing essentially assertions, get rid of syntax errors, then write assertions, write the code to match this. At this point, in theory, I've written something called a test. Now, it's not really a test. This is essentially a specification that the code has to meet. I've explored some requirements. Here's my basic requirement: can add 2 numbers. This isn't a particularly good example in this. Now I could keep going, and I will keep going to build up the code, but you see that we're lacking, because of this example, the domain that this code has to sit in, the actual requirements for this. How do I know that my add method is acceptable? Because I haven't created the acceptance criteria yet. So I'm building up the requirements and the acceptance criteria as I go through the process of doing this TDD. And that's mainly because it's an example. Normally we'd start with acceptance criteria. So in order to make this example a little bit better, I'm going to create some acceptance criteria. So I'm going to say 0 plus 0 should equal 0. What else do I think would be acceptable? Let's say 100 plus 1 equals 101. Now, at this point, I could keep going. What we're really doing here when I put examples, in fact, let's put in some negative examples. Let's be nasty to the system and say minus 10 plus 4 should equal, what's that, minus 6. And let's say minus 15 plus 20 should equal 5. Ooh, giving it some tricky requirements here. But what we're essentially doing here is, if we were to map this onto domain, the domain is probably what school children of the age 7 or 8 learning how to add numbers underneath 100 with negative numbers. This isn't finance yet. We've just called it add 2 numbers here, but really I'm dealing with integers. So the domain controls the code that we write. The usage that we want for this code determines how we're going to write it. Now, one of the things we face is that when we create code using TDD, we might later on in the application use it in a situation that we didn't expect. So here I'm writing code for small numbers. Later on, this calculator might get used for finance calculations, at which point it will probably fall apart, right? But that's because we're building code against a specific domain. So what I'm really doing in here is expressing acceptance criteria, expressing the requirements and using those to build up the code. So the code at this point is only going to meet those requirements. So let's finish this and we'll actually get some working code, because at the moment this doesn't work. So let's commit a cardinal sin and copy paste. So, and also I'm adding more assertions at one test. A lot of people don't like doing this, but I'm doing that. So we know that I'm expecting 101 when I add 100 and 1. So let's run that. Now this test should fail because we haven't coded for this. So let's write the code for this. Now I could, in theory, say if the first is 100, then return 101 else, but what we'll do is we'll just add these two. So I'll return first plus second. I'm expecting this to pass. And it didn't, because I didn't add in the values. There you go. Let's, now that we put in the correct requirements, there we go. So I can keep going here, and I will keep going to meet the acceptance criteria, because what we're going to see is, in reality, I've written enough code at this point to flush out the requirements. All I'm doing now is demonstrating that the acceptance criteria that we've said are correct or are good enough, or that we have met it. But at this point, I'm not adding any more code. I'm adding acceptance criteria. So are we at this point testing? Are we at this point just validating requirements? Are we at this point just demonstrating that the acceptance criteria has been met? I'm certainly not thinking very much, because I've got the answers written down. I've got the acceptance criteria, the expected results sitting there. So let's add this. I haven't even run, I'm so confident that this is going to run. I haven't even, that this is going to pass. I haven't even run this test yet, which I should have done at writing each point of the code. So this is the stuff that I used to build it. This is my TDD code. This is my acceptance code. But at this point, have I actually tested it? Have we done test-driven development? Just because this is called a test doesn't necessarily mean it's test-driven. So let's have a look at this from a testing perspective. From a testing perspective, I know I haven't done enough. If the domain is simply small children adding numbers, this is probably good enough. But from a test perspective, I haven't checked that the ordering makes a difference. So I haven't checked that if it's +4 plus minus 10, that we still get the same result. I should get the same result, but I haven't checked that yet. So my testing process is come up with an idea, then I'll write the code to check that, because what we've really got here is, let's run this and see. So I'm adding 4 and minus 10, which should be exactly the same. So the testing process came up with new ideas. In this case, it's irrelevant given the code that we've written. It might become relevant in the future, but really when you do TDD, you're not supposed to think too much about the future, because then you're going to write code you might not need. I now have to maintain all of these assertions going forward, and really they don't add value to the code or the design of the code or the ongoing maintenance of the code. What we've really got here now is we've written code that is called test. We use it as part of our test process, not because we're testing at this point, but because we are, every time we run it, reasserting that the expectations which we check are still correct. So I have an expectation that 4 added to minus 10 is minus 6. I have written a check for this, a way of checking this, and then I assert on that. So I reassert that a particular expectation, when we check for it, still works. That's slightly different from testing, where we've had arguments a long time about whether checking and testing are different. And we can see the subtle nuance here, that a check is something that we do and we can automate, but the testing process led to this. Now, if I was really going to test this, one of the things we have to do is go, is this domain thorough enough? Now, clearly, I'm not adding 2 numbers here. I'm adding 2 integers, but I'm not even exploring the scope of integers. So I could do that. I could explore the scope. Now, what's interesting here is I can't remember what the integer values are. So I'm going to say, just to give me a clue, system.out.println integer dot, there we go, max value. Let me just run this, print that out. So at this point, I am using my automated code to explore the domain to help me build new tests. So in theory, I could say what this plus 1 equals this, right? Then I've added 2 integers together, and we'll see if our calculator handles that. And at this point, I'm testing. This isn't one of the requirements. I've just made up a new requirement, because that's what I do when I'm testing. I go, can it do this? Then I check, and we know instantly that it won't do this, because it's not an integer at this point. This is bigger than an integer, but it's a number. So this code can only handle things up to this max value. It can't go bigger than that. It will fail. So say I don't do assert equals. Say I do, I wonder if I can do assert true on this. Let's have a look. assert true that this thing, whatever it is greater than. Nope, not allowed to do that because this still is comparing as an integer. So this is presumably is a long. So maybe the calculator should be returning a long when it adds two integers. So now I can have a long, but does that invalidate my method? Clearly, in order to cope with high values, I need to return a long when I add integers, but should this calculator be returning integers, or should it be returning longs? I don't know because the requirements aren't clear, but I know at a unit level, I have to change the code in order to meet these, to meet this specification. There are only certain things I can do at a TDD and unit level. Now, that's because I'm coding at a test. Later on, this code might have failed if it was still an integer return value because there's no test for it, but there's a usage where we throw in max value and add them together, and perhaps then it fails. The testing part essentially happens when we then start pushing the boundaries, when we start questioning the domain that has led to this, when we start seeing whether there are missing requirements. That's all part of the testing process. And very often we don't do that when we do TDD. Questioning, this isn't adding two numbers, it's adding two integers. Then it's a bit more sensible. This isn't actually a calculator. It's only got one method called add. Shouldn't this really be not a calculator, but an adding machine, an adder, rather than a calculator? Because it only has one thing. So I'm going to call this adder. So this isn't really a calculator test, it's an addition test. But is the requirement to create a calculator, or is the requirement to create an addition? These are in some ways design questions, in some ways requirement questions, in some ways testing questions. If we don't, we can view it as testing because we're asking those questions, and later on when we come to test it, we need to know those answers. We can view it as exploring the requirements, and because questioning is part of that and tightening up and building requirements. If we don't do that when we're at the requirement process, then we do that at the testing process. And it's the same process, but based on the stage we're at in the development, we call it something different. When we're questioning it because we're testing or because it's a tester, then it's thought of as testing. If we do it when we're the business owner or the requirements specifier or the designer, then it's designing or analysis or requirements. It's the same process, but based on the person or the stage, we might call it something different. But it is essentially a testing process, but applied at a different point. But we don't necessarily need that testing process when we're doing TDD to build the code from a predefined set of requirements. I'm hoping that kind of makes sense, that testing goes beyond TDD, that when we push our TDD code, we then have questions to answer, which we can't answer in the code because we need to know whether this is the right thing to do. I don't know whether turning this into a long to handle big integers is the right thing to do or not, because I don't really know the usage that this is in. But by specifying this, in fact this isn't, so by specifying this as two integers, really it's two ints rather than integers, because integer is an object. By calling this adder, I'm limiting the scope for confusion in the documentation here. So I'm going to check all this in, even though it doesn't add much value. I'm going to take this out simply because I haven't put enough code around this to really handle longs. So I'm going to leave this at this point, knowing that it does not handle longs or max values, and there's a limitation in the code that I've created. Thank you very much for sticking this out.